I wanted to talk a little bit about the core patient data and the controls, and just remind folks that the inclusion and exclusion criteria are exactly the same for these two studies. They truly are companion studies. We both use the same database entry tool, and there's probably about an 80% overlap in the data elements that we collect between these studies. So we were targeted to do 3,000 subjects. One of the things that we're doing differently is we're collecting controls as well as collecting TBI. So what you just saw was all TBI subjects across this spectrum from concussion to coma. So you also saw that we had an ER cohort, we had an admission cohort, and an ICU cohort. And that was designed to look at the question that Nino just raised is, why are these practices somewhat different than what we had seen before? And I'll talk a little bit more about that. The goals were to improve diagnosis and classification, as we've been talking about, improve outcome assessment, and I have another talk that Andrew asked me to give today where I'll talk a little bit about some of our experience with our large outcome battery, to really look at this health and economic impact of mild TBI. So many of us have focused on severe TBI. This is where we started from an operative perspective, from an ICU perspective. But I think as we've been doing a lot of imaging studies and following people that have milder forms of injury, we're finding that mild, even though we call it mild in this trichotomized mild, moderate, or severe, if you're not working at 6 months and you're disabled, then there's nothing mild about that. So we were trying to better understand that and look at the health economics of that. And then again, like Andrew pointed out, to create this information commons to really try to mine this in the future. And so I would say that, standing here 4 years into this, I think we were a bit naive about the data curation challenges that we were going to face when we started looking at all this. And I won't belabor that too much, but it's one of the reasons why things aren't moving as quickly as we would like. So Andrew this morning, and again, mentioned this notion of precision medicine, and I think it's a very appealing idea that, we take these diseases like cancer and heart disease, where most of the stuff, and you start off with almost any, we are definitely behind on this, aren't we? Sorry about that. We start off with, this idea of precision medicine. It's very appealing because most diseases start off at the level of symptoms, whether it's diabetes or whatever, and then you move into some of the details below that. And we all are very interested in the imaging, and we think that imaging can add to a coma score, for example. And then all the clinical data that we capture, we can't really harness that in the way we would like to. There's a lot of emerging interest in blood-based biomarkers, and then as mentioned, this genetics that I think there are some people that feel that genetics really aren't going to be that valuable in TBI because you have an injury, but I think what we've seen from some of our preliminary papers looking at hypothesis-driven, specific polymorphisms, that in fact it does drive this in a subset of patients. So one of the problems here, and for future speakers, what I'll tell you is this thing is out of sync with the thing. Okay, so. No. So if you can do it, I can do it. That's right, exactly. See, now we're going to get into our brotherly love thing here. So basically, yeah, it's a cognitive test. Thank you. Yeah, and I fail miserably. So basically, one of the things that we didn't really appreciate is that previously when we had done these studies like PROTECT and some of these other things, that we were dealing with what I call sort of a cookie cutter study where everybody had the same outcome battery, everybody had the same imaging, everybody had a very streamlined data collection form, and this stuff was actually not so horrible to clean up. You could spend 6 months with a statistical team and do that, and we really don't really have that. So what we have is we've been talking about this ED stratum, we've got the hospital stratum, those that got admitted to the hospital, those that got admitted to the ICU. And in addition to this, we also were trying to pilot a group of common data elements for kids. So we've got about 200 kids within this study, and their outcome measures are very different than the adult outcome measures. We have trauma controls, and so the trauma controls are necessary to make sure that just general trauma doesn't elevate a blood-based biomarker, or what are the post sort of psychological health effects of a traumatic injury. And then also looking at some of the background, because we know that in a large segment of our population, it's not what we would call an equal opportunity disease. I mean, there is a group of people that seem to find themselves in harm's way to become injured, and as a result, we want to look at what we call friend controls. So we actually have two different control groups, the trauma controls to control for the trauma, and then the friend controls to try to control for some of the socioeconomic background. So it's this notion, friends of a feather flock together, and so you probably would notice that most of your friends are probably more like you, and we find that our trauma patients, as they're coming in and they they volunteer their friends come in. Their friends are actually quite like them in terms of their socioeconomic background. So this is actually starting to work. So right now, we've got over 200 trauma controls. We're probably at about 35 to 40 friend controls because that was being funded by the TBI Endpoints Development Group. So I think we're going to have some very important controls that will not only be important to track TBI, but I think also to CENTER-TBI and some of these other studies, it'll be something nice to compare to. So for example, with the blood-based biomarkers, we're learning that trauma controls aren't really trauma controls. So you think that somebody's got an orthopedic injury, and they do, and you know, your research coordinator said, well, they don't have TBI. Well, actually, they do when you do an MRI scan and you look at some of these other things. So again, it underscores the importance of biomarkers and being able to go and suss all this out, and it shows you how complex this is. So we've got CT scans, we've got what we call phase 1 MRI. So this is the sequences that were developed that are very much like the sequences that are being used in CENTER-TBI. We use the phantoms to get standardized data, but then we have an add-on study that was funded by the Department of Defense looking at high-definition fiber tracking. So this is another way of sort of like the next generation of tractography, and so we're doing that as well. And we also have what we're calling the phase 1 blood-based biomarkers. So Andrew mentioned you know, about doing the blood work. We actually, because of funding from the DoD, we were able to set up our sort of a regulatory type biospecimen repository. So all of our biospecimens get moved by World Courier, et cetera. It's very expensive, and we could not have done that with the original funding, but what it's allowed us to do is to have a set of biospecimens that's regulatory ready, that this data can be analyzed and then shared with the FDA to try to look and see how we might plan a pivotal labeling study for that. So we had to add on some sites because I think we started slowing down. In particular, what happened is that we noticed, as you've noticed in CENTER-TBI, that in these 3 cohorts that we had almost no what I would call real severe traumatic brain injury like we grew up with in our ICU, because we were finding so many people were being admitted there with a GCS 13, 14, 15. And what was driving that decision was the CT scan. So we wrote a paper a couple of years ago out of the pilot showing the biggest factor driving a patient into the ICU was the results of their head CT. And I think many of us would acknowledge that that's kind of how we take care of patients. We don't just say, oh, GCS of 8, here's where they go, right? I mean, GCS of 8 is very important because if you look at the paper that, you know, Graham wrote a few years ago with Andrew and others, and you can see that as the GCS goes down, the probability of your imaging findings goes up. So it's a very helpful, you know, litmus test as to how to drive the clinical care. But then what happens is you've got a lot of these people with 13s, 14s, and 15s, and when they get that CT finding, it drives them into the ICU. Well, we were concerned that those kinds of findings were not going to give us the range of outcomes that we wanted to see with our measures, the range of biomarkers, et cetera. So after 1,400 subjects, we shut down the emergency department arm because from our perspective, we felt like we had enough data to answer some of these questions about patient triage, and we wanted to do this. Even with this, we had to add on more sites to continue to bump up the more severely injured patients in the ICU, and that's what we've been focusing on now, is getting some more sick patients. Again, the complementarity of the studies here, you know, what you guys have that's different than what we have, we should be able to share and look at that. Age distribution. So this is the age distribution, and this looks like an old school age distribution. If we looked at the CDC numbers of what the age distribution is in the States, you would see a bimodal distribution. Okay, and so you have to say to yourself, well, how generalizable is this? Well, I think it's generalizable for these groups. It's not generalizable for the elderly patients because we didn't study them. Why did we not get the elderly patients back? Because we do an outcomes battery that has over 20 outcome measures. We do, you know, over an hour of MRI scanning. And what we found is that, you know, between the combination of ruling these folks out with the cognitive issues, which we just talked about, and how grueling this thing is to come back at 2 weeks, you know, you got 3 months, 6 months, a year, we found we've got to do something different in our environment for the elderly patients, and we're thinking about how to have a different outcome battery with them and so on and so forth. In terms of the enrollment type, this still looks relatively distributed, but then what you can see here in this hospital admit with ICU is that basically we're bumping up on that and dropping down on the folks that we have that are in the ER cohort, because as I said, we just shut that cohort down. We're getting some of the controls out of there and so on, but we're trying to build this up, and even as we build it up, we're still not getting the level of severity that we want to see. So I think that one of the gaps we're going to have from TRACK-TBI is not enough really sick TBI patients. and we really need that. And so that's something for us to consider moving forward. In terms of data, we were looking for big data, and that's what we found. So this is just some of the curation metrics of first group of patients that we had. This represents 2,245 patients, and you can see there's millions of data points here. So we are on target to probably almost double the size of this, and we haven't put any of the data in for the biomarkers, the genetics, or the imaging. Like you guys, we've got lots of CT scans. We have many, many MRI scans because we were very MR heavy, which basically is why we didn't get so many elderly folks, but we have a lot of MRIs. We have many, many biospecimens. So one of the things that's a little bit different is that we were able to collect PAX gene tubes. So we're going to be able to get RNA at all these various time points. And we have both plasma and serum. So we have both, and so that's going to give us some flexibility. And the other thing, and I'll show you an example of, we're getting brain donation. So it's going to be very important to understand, really since the work in Glasgow, there's not been good brain pathology on these patients. And so we're trying to resurrect that. And we now have, I think, 9 brains, and I'll show you some analysis of the first one. So this is the pipelines that we've built, and I think there's been a lot of infrastructure because there's not been a turnkey solution to do this. So yes, our data entry tool is not great, but it works, but getting the data out of the back end is a problem. We've tried multiple applications to put it in the back end. We still don't have anything that runs, and still all these data sets live in different places. So we're eagerly looking to find some way to merge all this into one thing. Doesn't yet exist. This sort of puts into perspective, at least with the U.S. studies. To give you an example, the PROTECT study, which is over here on the left, which was one of those sort of cookie-cutter, streamlined clinical trials, very little data with 800 patients. You see where we are here, and we're projected to go above 8 million data fields here, so it's a lot of data. I found this slide because Andrew and I spent a lot of time talking about this. We're sort of drowning in data, and it's not because it's big data. Big data is not a problem. There's all kinds of infrastructure to handle big data. The problem is we have complex data. And just the thing that he was talking about with the GCS and all these other things, there's not an off-the-shelf thing that helps you to figure all this out. So until we develop those tools, which we're all both working on, I know Pradeep and the folks at INCF, and we're all trying to work on this, but it's sort of pioneering work because there's no other applications out there. So again, we've been looking at these cohorts for data analysis. We've pulled out some early cohorts because for us to stay going, I think Center got 7 years of funding. Is that correct? And we have 5. So we've had to pull some data sets out to get some papers written to get some follow-on funding here. So the CER cohort was a natural cohort because we stopped enrollment at the 1,400. Same thing with the MR phase 1 cohort. We only did so many of those scans. And then we had an opportunity to analyze biospecimens on the first group of people here. So we've got these different cohorts, and the sizes of these are right around about 1,400, 1,500 apiece. It's enough to start making some inroads in some of the early analyses as we move on from this. We've tried to develop tools to allow us to work better together. So this is what we call the production board, because within these cohorts, they're not all the same. And rather than everybody having different pieces of information on their computer, we're trying to use a more modern approach where this is up in the web, and people can get on this, and we can share things like this is our consort diagram for the different folks that are within this. We can do things like pull up, what is our follow-up rate? So this is in the CER cohort, so you can see our follow-up rate at 2 weeks for the GOSC is about 85%, drops down to 72% by 6 months and 67% by 12 months. The imaging cohort's a little bit different. Somebody that was committed enough to come back for an MRI scan, first of all, to get one at 2 weeks and then to get it at 6 months, those folks, the follow-up rate is north of 80%, so it's actually quite good. So the different cohorts have a little bit of different rate of follow-up, but the overall follow-up is more consistent with the CER cohort for the whole study. In terms of some early results here, we've been trying, we don't have a registry, so we're going to be looking to you guys to see what you get out of the registry. We've been doing some population-based studies. So we looked at the state of California where we capture hospital and emergency department data. And what we've seen in concert with the CDC statistics, we've seen adjusting for population growth, a 40% increase in the number of people coming to the hospital. So this is a combination of raised awareness and also the problem of elderly TBI, which is exploding in our country. The follow-up care is poor. We looked at people that had a GCS 13, 14, 15 mild TBI. Less than 50% of these people had been seen by a doctor. at 3 months. And when we looked at these folks, less than half of them were recovered. So here we've got a huge unmet public health need with people not being followed up by something that we now know causes problems. Now, all mild TBI? No. Our places are all level 1 trauma centers, so there's a selection bias where we've got more significant injuries coming in there. We're also looking at the health economics. We have a study that we have that's out in review right now, looking at claims data from insurance companies, and we're estimating based upon that just for the diagnosis of concussion in the United States, it's $9 million a year. In terms of, we just talked about this, CT is really driving a lot of our decision-making in hospitals today. We're looking at relationships to mental health and epilepsy, best practices for outcome assessment, a better understanding of the GOSE, which I'll talk about, and validation of the biomarkers. So very quickly, I'll show you just a couple of pretty pictures here. So this is some of the work that we're doing in and around the different pipelines that we have for imaging. So we're doing DTI, we're doing resting state fMRI. We've almost completed the volumetric analysis of all of the MRI scans that we did at 2 weeks and at 6 months. We're looking at different types of tools here. That the blue in the middle is a neurite outgrowth density type measurement. They call it NADI. The other thing that we've done too is that we've standardized. So everything that we're doing is standardized across all 3 of the major vendors. So we're not getting just qualitative data, but quantitative data. So from an analysis perspective, I think we're going to see a lot of benefit to this as we move on. One of the questions that we've had also is what does all this imaging mean? For the imagers in the room, I should probably apologize in advance. I mean, not a lot of this stuff doesn't have ground truth to it. I mean, you look at the data this way, you look at the data this way. So what we've been trying to do is put some ground truth to this. So this is a patient whose family graciously donated their brain. This is some ex vivo 7T imaging that we have here looking at the brainstem, sort of carrying on some of the work that David's group and others have done. And so this is some high-resolution tractography through that hematoma that we're looking at. And we're finding that these hematomas don't disrupt all pathways. Some of them are disrupted, some of them are partially disrupted. Like with everything in TBI, the more you look, the more complicated it gets, but this provides us with some reference. We've started looking at all these biomarkers that people have been interested in. This is just an early study showing the receiver-operator curve characteristics that GFAP, UCHL1 look very good, and this new marker that Heinrich Zetterberg's been talking about, the NFL, neurofilament light, looks like it's going to be a player in all of this. So, there's a lot of things that are happening right now. There's a lot of data that's being cleaned up, and there's a lot of opportunity, I think, for us to really share some of this, work together in a collaborative way. And I think the next 5 years of all these papers coming out is going to be very exciting. So thank you very much.
Okay, questions? So I've got a question, Geoff. You didn't envisage TRACK-TBI as a population-based study. You're not looking for internal validity. You're looking for a spread and density of data so that you can get precision medicine. How will you relate your data to the California, or those are 2 separate sort of studies, the California?
Well, we were sort of looking to see what those populations look like. And so what we can see is that if we look at people sort of under the age of 65, that our data looks very much like California looks like under the age of 65. And so we had a sort of an unintended systematic exclusion of elderly people because of what we were asking them to do for this precision medicine study.
Geoff, on a different tack, we both know each of us have strengths and weaknesses. Maybe the registry we have is a strength. One of your major strengths is the controls. And one of the things I regret now is that we did not implement controls other than for the MR scans initially. When we look at the biomarkers, do you think we might be able to use your controls also, the data from that?
I'm sorry, we were just talking about that.
Nino was distracted.
No. So
the question is, would it make sense in the analysis of CENTER-TBI to perhaps include your controls as reference?
Yeah, I think
then
so.
I'm particularly interested in the friend controls.
Sure, yeah. So the controls are going to be very important. And so we're going through, of the 200 controls that we've looked at, and by the controls, I mean orthopedic controls. So they were supposed to have no traumatic brain injury. They only had orthopedic injury. So we wanted to control for the inflammation of an injury and also the psychological health consequences of this. And we found that about 110 of these so far are really controls. We are now going through and doing a deep dive on these other ones that we're finding positive MRI scans on, positive blood marker elevations on. And so I think we should definitely be sharing some of that with you. And if anything, we should probably figure out how to get some more of this. So I think what we're trying to do, and this is probably a bigger discussion, is, how are we going about analyzing the biomarkers? So because we were doing so many blood draws over time, our IRBs would only allow us to ultimately get about 2.5 mils of plasma and 2.5 mils of serum. And for any of you who've done this work, this is going to go very, very quickly. So we are only analyzing biomarkers that have a regulatory pathway in front of them for now. Working with companies that seem to have something that's moving in that direction. This is not a discovery data set. So, but I think we should definitely be sharing our control data with you for a variety of reasons.
Just to be devil's advocate there, because your controls are going to be done in different platform, different sort of analysis tools, we might be able to take the general message away that a proportion of patients who present as controls have an occult TBI, which is, I think, an important message to take. But you won't be able to necessarily take the ranges that you get from your true orthopedic controls who've got normal MR, no change, and compare it to ours. Or do you think...
Well, what I'm proposing, because Andras and I had many talks when we were putting the biomarker thing together, I mean, you guys' protocol's very similar to ours, if not identical. And so I'm proposing actually giving you guys some plasma or serum, with what you've got to be able to run it to do that. The other thing that we've been doing too is we've been obtaining healthy control bloods from our research coordinators and friends at the University of Pittsburgh and UCSF, and so we thought we were doing great with having 50, and now we've been talking to our statisticians. We're going to probably bump that up to about 250. But that again, Andras, is something we'd be happy to share with you because they are truly normal, and out of the 50 or 60 that we've run so far, we've only had 3 with GFAP and UCHL1 that have peaked above anything that was detectable. So. Again, this is where I think we can share because we want to be able to look at I think you've got the registry data, we've got some of this control data, and we should figure out how to work together.